Hello and welcome. I am that Fabric guy. My name is Bas Land and here on YouTube I teach you all about Microsoft Fabric. And today we're going to look at the second video in the series on Delta Lake called The Anatomy of a Delta Table, where we will diving into what is actually inside a Delta table. Delta tables, they might feel like magic until you realize they are just files, right? It's not magic. They are files, but they are very organized files. In the next couple of minutes, I will show you exactly what is inside the Delta table. We're going to look at the data files, the transaction log, and how versioning actually works. So let's dive into my laptop and we can show how it works. All right, here we are looking at the Microsoft Azure Storage Explorer, and we are looking at the same Silver Lakehouse that we looked at in the previous video. And today we're not going to look at the taxi zone lookups, we're going to look at a larger table that is the silver yellow table containing the records for all the yellow caps in New York City. When we open the folder, and we basically open the Delta table, you can see that there are many different Parquet files in here, and that the Parquet files are a lot bigger than we have seen in the previous video. There are hundreds of megabytes, and there's almost 200 files in total. So there's gigabytes of data in this Delta table. And then for that Delta table, that is not big at all. Okay, so Delta tables can handle massive amounts of data easily. All right, what do we see here? We see a bunch of Parquet files. And as I mentioned in the previous video, these Parquet files, they contain the actual physical data at a point in time. So it can be that there is overlap between the same records in multiple files, or that records are missing from certain files or not. And the Delta logic inside the Delta log is maintaining all of that information. So looking at the inside here of our Delta table, and we can scroll through the Storage Explorer just like that, we can see that there are many files. There are large files, and we're not going to open the Parquet files because the Parquet file is compressed and we cannot simply browse it as if we were browsing a JSON file or a CSV file. Now the Delta log is something we can actually open, and we see that there are many different JSON files in here. Actually, there's over 200 JSON files in this Delta log, and every JSON file is a commit to the Delta table. And now what I can do is I can show you a preview of what is actually inside that JSON file, because the JSON file here is the actual commit pointing to a data file in the Delta table. And now what we see here, let me break this out a little bit so that it's easier to read. What we see here is that we have some commit information, some metadata, a protocol that's being used, and the add of a data path. Now let's start at the commit info. At a certain timestamp, an operation was executed, and in this case it is the first file. It is 0.json. This is the initialization of our Delta table. The operation was create table as select, and that basically means we have been running a query on another table, selecting data, or basically running a SQL select query, and then creating the table as a result set of that query. Now there were different operation parameters, and we're not going to scroll through the entire file in here, but there are a few things that are important to know. That is the operation parameters that were being used. There was no partitioning and there was no clustering. More on partitioning and clustering later in this series, by the way. It is a managed table. This is something that is very important to have, and there are a few Delta properties that are enabled or disabled. In this case, the Delta Parquet V order is set to enabled, and V ordering is very important in Microsoft Fabric if you want to do Power BI Direct Lake. Now more on V order as well later on in the series. What do we see here on the metadata? We find actually that there's a format Parquet, so we're using the Parquet file format to store data, and we have the entire schema of the table in here. We have the name of a column and the data type of that column, and then can it be nullable? Yes, it can be nullable because this property is set to true. And in this way we have all the columns defined with their data type, their names, whether they're nullable, and so on. Then the protocol is not that important. The important part here is the add. And what are we adding? We are adding a reference to a path, and that path is called blah 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 .snappy.parquet, and this is actually pointing towards, in the root folder of the Delta Lake, of the Delta table, it is pointing to that Parquet file that we are referencing, the physical storage that we have there. It is storing the size, it is storing the modification timestamp, and that means that it can look at this information in order to find data on the storage very quickly. We're also storing a lot of metadata in here. We're storing the number of records in this file. So in here we can find that we have 14 million rows in that single Parquet file out of the 200 Parquet files. We have minimum values. So for a couple of columns, the total amount, the store and forward, the trip distance and so on, the minimum values are 0. And this is used to quickly scan the metadata, to quickly scan the delta log. When you write a query that is filtering, we can omit certain files. We know that metadata also stores maximum values. Here we have min values, min values, min values, min values, total amount. So apparently the minimum value for the field total amount in this dataset is 10.0. Now, if we are selecting a query, select star from table where total amount is 5, then the Delta engine doesn't need to scan the 14 million rows in this Parquet file, because it can look at the JSON file right here, find the total amount, the minimum value is 10, so that no single record in this file contains 5. So we can omit the entire Parquet file, we can omit those entire 14 million rows when we start reading data. And that is what makes Delta operations so incredibly fast, is that we can look at metadata for the files like this. Now, as you can see here, 0.json, 1.json, 2, and so on are the actual commits that have been happening to this table. There can be insert, updates, and deletes. And you can see that every 10 commits, basically, there is a checkpoint. And what this is doing is that Delta is storing the state of a table at a point in time in order for the engine to more quickly query the table. So we can say, if we have hundreds of transactions, let's go through all of those transactions to find the current state of the data. That's not very efficient. So what Delta is actually doing is it is finding the most recent checkpoint and then the transactions that have happened since that checkpoint. And if we do that, we have the current state of our Delta table. So to recap very quickly, a Delta table is a folder within your data lake. It contains Parquet data files. We've seen those. There were a couple hundred Parquet files in there. And we have a Delta log folder, the _delta_log. That log is basically the brain of the Delta table. It contains versioned JSON commits and it contains checkpoints. Now those commits point towards a certain file or files. It contains metadata on those files and it contains metadata on the transaction itself. When was it run? What was the operation? Was it a write? Was it a read? And so on. Together, those Parquet files and the Delta log, they describe the full history and the current state of the data inside your Delta table. And that is how your files on a data lake start behaving like a real table, as if it were a database. Now the next video in this series, we're going to look at the Parquet file versus a Delta table. So stay tuned, like this video, subscribe to my channel, and see you next time.